Ian's got the, okay. Welcome, my name is Tricia Denton. I'm the president of the League of Women Voters, Leelanau County. The League of Women Voters is a nonpartisan political organization that encourages informed and active participation in government, works to increase understanding of major public policy issues, and influences public policy through education and advocacy. We never ever support or oppose candidates or parties. Membership is open to women and men, 16 years of age or older, who subscribe to the purposes and policy of the League. 1/3 of our members are men. More information may be found at lwvleelanau.org. Annual dues are $5 for students, $60 a year for non-student individuals, or $90 for a household membership. Dues assistance is available. Don't let that keep you from being a part of if you're interested. Membership applications can be found online, and I think our membership chair, Beth Childs, if you could stand up, identify yourself, she's in the front row. Talk to Beth if you're interested in becoming a member. And today's program is called Talking Trash. Thanks to all of you who showed up early to visit our various booths. There'll be a little bit of time after today's program to follow up with anybody that you didn't get to catch before we got started. And I'm going to turn the microphone over to Ann McInnes, co-chair of our Energy and Natural Resources Committee, who helped organize today's extravaganza. Thank you, Ann.
And thank you all for participating today. We want to have some folks who keep items from landfills, and hopefully that might be you. Since a landfill destination would be a complete waste of all the energy and natural resources that have been involved in the original making or growing or transporting or selling of those items in the first place. From their initial birth to their final and conclusion, their final end. So how do we do that? And who cares? Well, our Energy and Natural Resource Committee cares. The League cares. And we're sure you all care. And certainly all the non-living lives with whom we share this planet, they care. Today's Talking Trash Forum involves just one of the issues about which our committee has been researching, educating, advocating, and partnering with other like-thinking groups. Now, exactly what do we do with all those throwaway things in our overconsumptive society that we no longer want or can use? What do we do with them before they go to die? So, what can we do with all those worn-out clothes or shoes that no longer fit, or you don't like them anymore? Just what can you do with those kitchen scraps? Leftover food from preparing or eating a meal. You look there, and some in the back. Just what can you do with all the plastic containers and bags in which food and a zillion other items arrive? You can look around here. What could a sailor do with sails no longer usable? Look in the back with Janae. Or what could a do-it-yourself silver do with leftover paint and building materials? Or maybe a homeowner. What could the homeowner do with discarded old broken and tired furniture and other household items? What would happen if there wasn't ever a trash pickup to dispose of all the stuff you don't want? So, and then there's the plastics again. Plastics are everywhere. We found that from they're microscopic to huge. They're found in the tropics to the Arctic. They're showing up in our water, our soil, our air, the air we breathe, the oceans, and even in some of the food we eat. And they never die. Do you suppose that they even could cause negative effects on living things like us? And why would the Energy and Natural Resource Committee be so interested in this issue? Chances are you probably already are aware of the scientific evidence showing that our trash equates to a huge amount of wasted energy and natural resources. Even more significant is the evidence that our society's overconsumptive habits and abysmal practices of disposal of those things is increasingly undermining our own life support systems and that of other living things. In an era of precipitous loss of life's biological diversity among other living organisms, along with a catastrophic and uncontrolled climate disruption generated by using the atmosphere as a free dumping ground for waste emissions, we can no longer wait for someone else to do something. We're the ones. And the time is now. Today we're very honored to have, among all of these wonderful people who brought their wonderful exhibits, we're also very honored to have two very special experts who will fill us in on some of the details about what to do with the wasted stuff we have, and maybe not to get it in the first place. And then they'll leave us with some ideas on what we can do. So I'd like to introduce Marcia Harris. Marcia is the Vice President of Leelanau County Solid Waste Council. After teaching young children for about 20 years in a suburban Detroit school, she and her husband retired to beautiful Leelanau County in 2004, and then soon after, she became involved with the Leelanau County Solid Waste Council, and she now serves and has served for a while as its vice chairman. The council acts as an advisory group to the Leelanau County Commission and manages the county's drop-off recycling sites and household hazardous waste collections. We are always looking to improve our collection program and keep more items out of the landfill. Maria claims to be an obsessive recycler, and she's been known to rummage through her children's trash to pull out recycling. Moving forward, she'd like to see us continue to educate the public regarding the value of reducing our carbon footprint. And Andy Gale is the founder of Bay Area Recycling for Charities. Andy grew up in the Chicagoland area as the youngest of 8 children. His passion for skiing and mountain biking started in the hills of northern Illinois and Wisconsin, but soon took him west. The son of a master carpenter and a general contractor, he learned his work ethics and recycling on construction jobs, being taught to sort the metal and wood from the trash while loading up dumpsters gave him an introduction to conservation. After high school, Andy pursued both his skiing and his construction passions, attending Colorado State University and studied construction management and graduated with a Bachelor of Science degree. Andy continued heading west to California and began his career as an engineered wood products company After working 17 years for commercial construction, Andy moved with his wife and 2 children to Michigan to start the Bay Area Recycling for Charities. After 10 years, Andy and Bark have worked hard in education, sustainable change, and development of making recycling and composting a permanent part of our future. So let's give a warm welcome to Marcia and Annie.
One more quick announcement. We are in the Government Center, and I was notified they're going to be doing some training today in the building, so if you hear any odd noises upstairs, don't be alarmed. It's a false alarm.
Oh, boy. I have 2 quick anecdotes. The first one is about Andy, who came to the Solid Waste Council around 2010, introduced himself, talked about his new business, and a colleague and I looked at each other and said, gee, he's a cute young guy, but this is going nowhere. I'm so glad that we were wrong about Andy.
I'm not cute.
You're older now. And the second involves Ann McGinnis. Oh, there she is. Ann McGinnis taught science in a classroom around the corner from my classroom. And that's 25 years ago, at least. And if I would get to school early, there would be kids, she taught science, there would be children lined up in front of her room waiting. This is at 7 in the morning or 7:15, waiting to come in to feed the animals. She was the Pied Piper of the school, and she's the Pied Piper of everything good scientific in this county. So we're lucky to have her. Yes.
Still have one snake.
You still have one snake, really? Well, Andy, I'm going to pass this off to you.
Good afternoon, everyone. How's everyone doing today? Good. Great. So this is a 1-hour presentation that I can easily stretch into 2 hours if you guys want. But I'm being told that I think we're going to compress it to about a half hour because we want to get some questions in at the end. So I'm going to go through this pretty quick. If it's okay, if you have a very pertinent question, by all means raise your hand. We'll answer it relatively quickly. But if you want to save your questions for the end, we're going to try to go through this real quick and then save some time for questions at the end. Does that sound good? All right. So thank you for the nice introductions. I didn't know you thought I was cute, so isn't she cute? I mean, seriously.
Way over cute.
So, like Marcia said, I started this organization in 2008 and was joined the Solid Waste Council, and we're working together, all of us here in the room included, trying to make a better county for ourselves, a better world for ourselves. You know, we all love where we live. We embrace the nature, and we embrace the beauty of where we live. And so we want to keep doing these things that make us better stewards of our planet, right? So here we go. You guys buckled in? It's going to go quick. So how did we get here? This little chart, if you can see this, is our world population. And this is in the year 2000, and this is about the year 100. So we've maintained ourselves for about 100 million people on this planet up until the 18th century. And that's when the population growth started. And look at that spike, and that is amazing, of the number of humans that are on the planet. And we love our resources, right? We like all of our food, and we like to have our packaging, and we're consuming things at an unprecedented rate. I would make a joke up above that I am the next level of evolution, which I'm starting to hunch over like the third guy, and I've got a beer in my hand. But so that as we're evolving, our population is exploding in this planet. So we were talking about the industrial age, and that's where our population really took off. You know, there's an example here of what our house used to look like here 100 years ago and what our house looks like today. The family looks the same, a little bit more modern today. We've got all those kids could all have iPhones in their hands and be staring at their iPhones instead of with their family. So, but we've been very innovative also. So there's a picture of a garbage truck in the 1950s, and that's really about the time where the invention of plastic in the 1930s. We started to realize we just couldn't throw our waste out the window anymore. Where our waste was becoming more complicated. And so we started having things like, paper and plastic and glass and metal that we were consuming on a daily basis. So there's a picture of a garbage truck from the 50s and a more modern one today, the waste management truck there on the right. And then you can see what the old landfill used to look like. A quick story, when I was down at the Keystone operation where all of the leaves go from Traverse City, they all go to Keystone Road, and that's a dump there. It's not a landfill. A landfill has to have a lining underneath it and over it to kind of enclose all that material in it. And so the dump that was over on Keystone and they're doing the composting on top of it, I asked the guy that was showing me the facility there, I said, that's kind of an odd place to put a dump right next to the river. Like, why would you put a garbage dump right next to the river? And the reason is because all that trash used to go into the river. And they thought it was a good idea to not put it in the river, just put it next to the river. So we're getting so much smarter these days. So now we've engineered ourselves landfills, and that's good. This is gonna help protect, the environment around us. And so we're becoming more technically savvy when it comes to it. So these are our 4 basic packaging materials. So when we're talking about recycling, we're basically talking about recycling packaging, right? So the things that we purchase. So everything comes in a cardboard box. Almost everything starts off on a wooden pallet, and we want to try to control these waste streams so we can get this material back into the process of being recycled. So you all remember the old adage, reduce, reuse, recycle. Well, it's in that order for a reason. So our best opportunity is to reduce what we use the best we can. The second is to reuse what we can, and then what we can't reuse, we recycle. So that's the process. So paper, plastic, glass, and metal. Paper, around here in Michigan, it has really strong markets. We don't have a problem recycling our paper around here. When it comes to metal, metal's been recycled for tens of thousands of years. Metal is an element that is easily melted down and made back into the same material. So those markets are good. The plastic and the glass, on the other hand, is what we struggle with locally here. So I say local recycling is always as easy as 1, 2, 3. So you just have to make a plan for what you're trying to recycle. You have to sometimes do some research to find out where its home is. Clothing goes to Goodwill. Batteries, you can go onto the website here at the county, or you can go in the village where you're at and look at the website and find out where you can get those alkaline batteries. There's household hazardous waste collection days here in the county, and sometimes you just have to store those batteries up in a coffee can or something and take it on that day. And then the next step is to get it to the curb to be recycled, or take it out and put it inside your car and take it to the next place where it goes. So that's like the magic box, right? You put it out at the curb and then it goes somewhere. And we're happy because we put it in a bin that says recycling, right? So we're like, oh, this is great. We just recycled everything. Well, did you? Now it's up to the experts out there in the world that are going to have to figure out what to do with that material that they have. So it goes in the bin. Locally, we have a great organization called American Waste. They've got a huge MRF. All that material goes there. A MRF is a material recovering facility. That material goes there and it gets sorted out. There's different ways to sort it using optical eyes and little eddy currents creating different force fields that make aluminum magnetic for a microsecond, so it'll go flip over into a different waste stream, a different recycle stream. So there's that process. And then all that material gets baled up plastic, baled up paper, and it's densified because what we're trying to do is we're trying to get it to these markets in Grand Rapids and Lansing, Detroit, Chicago, Ohio. We're trying to get this stuff densified so we're being efficient with our process of transporting it. Because obviously you don't want to put, you're trying to recycle something, but if you put more energy into recycling it, than what you're getting for the value of that recycling, not value dollar-wise, but value as far as that resource, it might be better to landfill some things, which I'll never say in public. Shoot. So, household hazardous waste, we've all been to them. You drop off your electronics. Those electronics, they get broken down locally here. And then those materials get made into different things. So if you go to the furniture stores, sometimes you'll see these beautiful lawn chairs and things like that, and jackets and other things. You can see where these things are being made into other products, which is pretty exciting. So these are our biggest losers, the glass and the plastic. The sad thing is that glass is, if you go back to the old clay pot that we've been using for 10,000 years, that's our oldest substance. Glass is just a clear clay pot, right? So it's really sad that there's no good reuse of that market. The glass around here basically will get ground up and used inside the landfill as road base, which is a nice last use of that material if that's, it's inside the landfill though, but it's material that they don't have to go and bring gravel in from other mines or areas to bring in that aggregate material. It'd be nice if we had more glass recycling up here. There's artists in the audience here even that do glass art and glass recycling, but obviously it's just not enough to take care of the amount of material we have. And it's a heavy substance, you know, it's sharp when it breaks, so it has, everything has a, you know, a good thing and a bad thing about it. The plastic, you know, when it comes to water bottles, that is actually really high grade plastic. The PETE bottles are ones that you can recycle almost over and over, maybe 5 or 10 times. And so the laundry detergent containers and your milk jugs, that's a number 2 high density polyethylene. And so that material also has got good markets. It pays enough, when people recycle it, it goes, you know, gets into the recycling stream and it finds its markets even here in Michigan, which is great. So the other plastics, the 3 through 7 plastics, that's the other half of the plastic that we use. So the water bottles and the milk jugs and the laundry detergent containers is 50% of the plastic that we use out there. The other 50% is all of this other stuff, this film and these little bags and the styrofoam to-go containers. And even this has got plastic in it. This has got a polyliner in it. And you know, there's just so much of it. And that's what we're trying to figure out right now as a society, not just locally here, but globally. We're trying to figure out, where does that go? What can we do with that? How can we repurpose that and make that work? So, the opposite of paper, plastic, glass, and metal is composting. So food waste, that's our organic materials that we have in the kitchen. Who here has a backyard composting operation? There you go, look at this, it's amazing. More than probably 3/4 of the people here. Do you have a question back there, sir?
I did, and it was regarding the glass.
Yes.
Is the process of pulverizing it, is that something new? I always thought glass was remelted and reused.
If it's being recycled, it's gonna get pulverized first into what they call a cullet, which is like a little gravel material, 1/4 inch. And then that cullet moves off to different markets when it's being recycled. And that cullet will get used, ground down even more into what they call a flour. And so that glass flour is what you turn back and remelt. So from what I understand, that's the process of turning, you know, a glass beer bottle back into a glass beer bottle. What they're doing right now is they're just grinding it up a little bit and using it as an aggregate, so when they drive on the landfill, that they've got a road base that's not sinking directly into the landfill.
The remelting is not being used very much anymore.
It is, they still do that, but the markets where those bottles are made, let's say Columbus, Ohio is an area where a lot of glass bottles are made for big manufacturing facilities. And that material that's being made, you know, Columbus only has to reach out as far as a few other cities in Ohio, and they've got enough recycled content material to take care of that plant. The problem is that up here in northern Michigan, there's no glass bottle manufacturing, you know. So there's other opportunities to do things with glass. We experimented with an idea with Evergreen Bottle Company to wash wine bottles and turn them back into reusable bottles, you know, for the wine industry. Because it's amazing, some of those wine bottles, they'll start off, they'll be made in Spain or Italy, and they'll be transported all the way across the ocean. They'll be transported all the way across the United States here to Michigan. They'll go into a winery, you know, they'll get in the basement in the winery. They'll pour that wine into that bottle. It'll move itself upstairs to the tasting room. It'll get poured. So that wine bottle got used and only moved about 25 feet vertically, and then it's been being disposed of. And they're very robust bottles. I mean, you've seen wine bottles. You can use that as a weapon, right? You know, people have knives on their kitchen table in case someone breaks. I just keep a few wine bottles there. That's what you need. So food waste composting. This is, as far as Bay Area Recycling for Charities goes, I find this to be the most interesting part of what we do. Because instead of employing just, you know, 10 or 20 people to run your organization, we're employing trillions of little microorganisms, so you don't even have to pay. Just got to give them some carbon to chew on. And they take food waste, and these are called windrows. You can see them steaming inside there. The energy, they're actually combusting that carbon. They're breaking those bonds. The way that they metabolize that food waste and that carbon material, that nitrogen and carbon mixture that you guys put in your compost pile, they're actually combusting it just like the way lighting a match will combust paper. They're breaking those bonds inside there, and they're breaking that material down. The thing we're trying to achieve here in Leelanau County is what's called an aerated static pile. And so this is a process where, if you look at the very first bin over here, number 1, so you basically get your ratio, you know, what's the ratio? Anyone here remember what the ratio of carbon to nitrogen is? So it's a 3-to-1, or 4-to-1, 3-to-1, okay? 3 parts carbon, 1 part nitrogen. And that's just when you're dealing with the carbon and the nitrogen, like leaves, 3 parts leaves, 1 part food waste. The actual food waste is made out of carbon also. So when you start to look at the carbon-nitrogen ratio of the actual process of what's in the pile when broken down by weight, you're looking at probably somewhere between a 10-to-1 to 40-to-1 ratio, because there's carbon in everything, right? Nitrogen, so that carbon-nitrogen ratio is important. So with the aerated static pile, you start week number 1 in that first bin, and you mix your carbon and nitrogen, and you keep it in that controlled environment. You allow the ability to control the moisture, the oxygen level, the carbon and nitrogen levels, and then that creates the perfect environment to get those microorganisms started and to start breaking down that material. After the first week, that material from bin number 1 gets moved over to bin number 2, and then you start over again in bin number 1. And what bin number 2 is doing is it's resting. It's gonna do its same thing over that next week. It's gonna heat up to 100. It's gonna go from 120 to 150 degrees inside that pile. And then week 3, same thing happens. Each time you just move it 1 week over to the right. By the end of the 5th or 6th week, that material that's in that right-hand side bin, it is not recognizable anymore as being food waste or compostable products or paper or leaves or wood chips or things like that. Those microorganisms have broken that material down, and it looks quite a lot like compost. It needs to be finished though. It needs to be put into a windrow so that last bit of nitrogen can be burnt off of it, and that last process. So you might turn these windrows with a windrow turner 2 or 3 times to just give that final finish to it. Otherwise, if you put nitrogen that's nitrogen-rich compost that's too rich into your garden, it probably wouldn't damage your plants that you have inside there, but you wouldn't have a very good luck trying to start seeds in it, because it's a little bit too hot still. Does that make sense? So composting, fascinating stuff. So paper, plastic, glass, metal, all mixed together is what we call electronic waste. So when you have all that stuff kind of smashed into like one thing, that's a computer, that's your iPod, that's your radio, it's your toaster. So that's electronic waste. And the amazing thing about electronic waste is that, well, 2 things. Number 1, it's the fastest growing waste stream in the United States right now. Paper's pretty stable, plastic, glass, metal, pretty stable. Electronic waste, the amount of electronic waste that we create every year goes up every year. And so there's collections, there's ways of getting it, collected and put into the waste stream, into the recycling stream, and then move downstream. And the most technologically advanced places we take it to in Chicago is a place called Kuzakowski, and they grind that material up. And again, they have all of these different ways to sort this material through these vibratory tables where the light stuff moves uphill and the heavy stuff moves downhill as these things are vibrating. They have eddy currents and ways to make the magnetic, make copper and aluminum magnetic for a microsecond so they can sort these things out. It's an amazing facility. It's like a 300,000 square foot facility, and they grind up thousands and thousands of computers every hour. Grind it up and make it back into other materials. And Kuzakowski, I think they're on 5 continents, so it's a pretty big company that no one ever heard of. Has anyone ever heard of Kuzakowski? There you go. They're the ones recycling most of our electronics on this planet. So household hazardous waste. So this is a tricky one, right? We all have this in our homes, under our sinks and in the garage. This is something that we have to take into consideration. But there's universal waste that happens, electronics and batteries and fluorescent bulbs.